Myself Awhan from IIIT team Karnool. Today I will be presenting my SIC project based on the topic emotion detection using CNNs. So what I will be presenting right now is one PPT. Is the PPT I have prepared this, and along with that I will be explaining the code parts. So let's get started. So introduction. The introduction in this part we first analyze the objective of the model. So the AI model basically classifies every expression that a human can give into, for example, anger, disgust, and sad, happy. All of that I have mentioned all of them, like anger, disgust, fear, happy, neutral, sadness, and surprise. So these type of classes have been there, and the model can define the photo, like whatever photo we provide in a training set. So it can classify the photo in one of those classes. So the data set, as it's written here, train and test directory, it's there in the train and test directories, as I have kept it there. Okay. So next, in our code part, we have to import the libraries. So these are the libraries that we are using. As you can see here, pandas, numpy, it's written here. Pandas, numpy, these belong to the data handling category, and matplotlib, seaborn, plotly, these belong to visualization. And for deep learning, we are using this model, pre-trained model, DenseNet 169. So we are just modifying that, like freezing its last layer and just modifying it according to whatever our requirement is. And this is the model that we are using, pre-trained model. And for evaluation, we are using this sklearn for all of these visualizations. And then we would set up this hyperparameters and directories. So as in the code we can see, and in the PPT we can analyze here, the key parameters that are defined here are image size, which is 48 into 48 pixel, as you can see here, and then the classes, batch size, and the learning rate of the photo. These are all the specific details of the photos that we are giving into the test and train folders, the data sets basically which we have provided for the model to train. And then these parameters, after giving these parameters, we would start the data pre-processing. It belongs to this part, this code. So in this code, we provide two features: horizontal flip and width and height shift. These photos, like these specifications of photos are the procedures which you can just, the model should optimize, like opt to optimize the training procedure. So this is the code corresponding to this explanation. And then as you can see here, this is the output. And then we have these display visualizer function, as you can see here, data visualization. So here, as we can see, we are basically displaying 9 images for an example for the user, that how the model classifies the images. So this is the code that we have written, like the display one image, and all of the 9 images we are plotting them in one single image like this. As you can see clearly, this belongs to anger, this belongs to sadness, this belongs to fear, this belongs to neutral, and then like that, like neutral, surprise, then sadness, and like that. So you can clearly see that. So we have plotted this just to give the user an example of how the model works and how you can implement into any code interface, such as for example an app, a website, or something. And then these all emotions we have put over here. So yeah. So next we would come to the model architecture. So here, as you can see, the feature extractor is this model, DenseNet 169. So as we have written it here, pre-trained, it's a pre-trained model, and these are all classifiers. We took it out from this model, and we use a predefined model just to get, like, this model is a very famous model, as if you would have done a little bit research on image classification and all of them. So this model has been used in many of the top companies. Those use, for example, online proctored exam, where you can visualize anyone's faces and classify their emotion, and according to that you can find out something that they're giving the exam properly or not, and this thing. So this model have been used already. So that's why we took this model. And as you can see, this model has these all levels of classifiers, and yeah, why does that? Because it's created and learns the features faster. Then we are training the model, as you can see. Yeah. Training and fine tuning. So in this part, we are training it in two phases. So in two phases, in the first phase we are only training the classifier with 30 epochs. Epochs can be said as a revolution. Like for example, how we complete one revolution over. For example, we make a round. We train the images, like the model, from whatever images we have stored in the data set. One round we train it, then the second round, then the third round, and like that we continue for 30 rounds until the model extracts all of these features and makes it more perfect. Then the phase 2 fine tuning, which consists of 20 epochs and it has a lower learning rate, as I have mentioned here. So these two phases of training the model, and then we get the results and performance. So the results and performance we have here, as you can see here. These are all the fine tunings and how it is rendering all of these epoch like outputs, like how is it like doing all the rounds of whatever training from the data set. And then we are plotting the training, like visualizing this thing, visualizing results. So we have three forms of visualizing. First one is confusion matrix. So this represents how the diagonal elements here, this row represents how best, like what are the best classifications of the model that has been done from the directories that we have provided in this data set. So as we can see, these are the best, and the best classification that the model has made is happy. So the model has got the most, the model has extracted most features, optimized features on this happy emotion. So yeah. This confusion matrix also gives the user about how the user has provided the images. For example, if we have provided not good qualities of angle images, then we can see that the angle part is not that good in this classification. For example, yeah, this discuss part we can see that it's not good in classification. So that in that way the user can know that which like the photo is provided and that's the best photo, so that the model can classify it. And then we draw this AUC curve, which we use this in analyzation. Yeah, so here as we can see, this accuracy and epoch graph and misclassified images are marked with a red. The incorrect predictions have been marked in red. So yeah, so this is the conclusion point of this PPT. Next we will talk about this future improvements and applications. As I told earlier, that applications would be possible in such as an online proctored exam, and for example in wherever cases we need to specify that the user is not a robot. For in that cases we can use this, and we can also use this in mental health analysis, smart surveillance. This in these fields it comes into use. So yeah, this is the conclusion. This was an AI project made by CNN, and this is the conclusion.